All right, welcome to 4.6. We're skipping sections 3, 4, and 5. We're jumping from section 2 to section 6, so make sure you're in the right spot in your note packet. We're going to be formalizing relations and functions today, and our essential question: how do you find the domain and range of functions? Okay, and this will be split into two parts. We're going to cover it over 2 days. So this is day 1. All right, so what is a function? A function says that every x has exactly one y, and this is very important. Exactly one. Okay. And so we need to ask ourselves: are the following things functions? Okay, so let's take a look at the first one here. Our rule is that every x has to have exactly one y. Okay, so this x has one y. 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 None of the x's are repeated, right? And so this is a function. Okay, now for this one, is this a function? Well, 1 goes to 4, 2 goes to 3, 3 goes to 2, 4 goes to 5. X's, again, are not repeated. And so every x has exactly one y, and so this one is a function as well. Okay, let's try this one. Okay, so we have 1 goes to 4, 2 goes to 2, 4 goes to 7, and 4 also goes to 3. So 4 went to two things, right? We had 4 doubled up. 4 went to 7, and it also goes to 3, so that means that it's not a function. Okay, and the last thing here. 4 goes to 4, 2 goes to 3, 4 goes to 7, 7 goes to 2. Is this a function? Well, again, we have 4 twice in the x column, and so no, it's not a function. Okay, there can only be, each x can only go to one y. All right, now, a relation, it's the relationship between two sets of numbers. And usually it's like a coordinate point, right? So like, you can look down here real quick. -3, 1, that's a relation. Okay. And kind of all equations are relations. Okay, so it's just a relationship between two sets of numbers, an input and an output, right? The x's and the y's. Now we're going to be working with domain and range today. The domain would be all the x's in your relation. The range is all the y's. Okay, and it's easy to get these confused, and so just try to keep this handy to reference back to. Domain is the x's, range is the y's. All right, so now we're going to identify the domain and range of each relation, and then we will represent the relation with a mapping diagram. Okay, and ask ourselves, is it a function? All right, so first off, we're going to do this a little bit out of order. I'm going to put this into a mapping diagram. And what a mapping diagram is 2 circles, or 2 ovals. Okay? And in this oval, we're going to put all of our x values, and in this oval, we're going to put all our y values. Okay, so for A, our x values are -3, 0, 1, and 2. Right? -3, 0, 1, and 2. Those are all our x values. Okay, and then all of our y values go in this oval. So 1, 2, 1 again. I don't need to write 1 again. I already wrote it, so we move on to 4. Okay, don't duplicate your numbers. Just write all of them that appear. If they appear twice, then just write them once. Okay, now we draw little lines or arrows to where it goes. So -3 goes to 1. 0 goes to 2, 1 goes to 1, and 2 goes to 4. Okay, it's easy to see here in our picture that each x value only has one line coming out from it, right? It's okay that -3 and 1 both went to this one. That's okay, because each x value goes to exactly one location. Okay, so this one is a function. And now let's write the domain and the range. So the domain, we do a little bracket, okay, just like these brackets. I can't draw brackets, so bear with me. I do squiggles. So we list out all the x values, so everything in the x oval. Okay, so -3. Again, you don't need to duplicate numbers if there is a duplicate number. Okay, and then we got our range, which is bracket, that's a terrible bracket, 1, 2, and 4. Okay. Now for this one, again, we have x values and y values, right? So our x values are 4, 5, 7, 5. Now remember, we have a duplicate 5, so we're only going to write that one time. So 4, 5, and 7. We have our y values, which are 6, 1, 2, and 2. Okay, we only need to write 2 once. So 6, 1, 2, and 2 again. Okay, last step. Where do they map to? So 4 goes to 6, 5 goes to 1, 7 goes to 2, and 5 goes to 2. So is this a function? Uh-oh. 5 goes to 1 and 5 also goes to 2. Since it came out two different directions here, it's not a function. Okay, so it's okay if more than one x value goes to a y value. Like this one, it's okay because there's only one line coming out from each x value. But here it's not okay because we have 2 lines coming out from this x value. Okay, we can still do our domain though. 4, 5, and 7 for our domain. And then our range is all the y values. And so it's 6, 1, 2. Okay. Now we need to determine is the relation a function. And we're going to use the vertical line test in order to determine that. And if you remember in section 2, we talked briefly about the vertical line test. So what we're going to do is we're going to plot these points. Okay, so -4, -4, 1, 2, 3, 4, 1, 2, 3, 4 down, -4 is right here, and then -2 and up 3 is right here. 3, 0, that would be to the right 3, but then you don't go up or down any. 5, 1, so for 5, 1, and 6, 1, which would be right next to it. Okay, now we use our vertical line test to ask ourselves, oh, that's not a vertical line. Does a vertical line go through our points twice? And in this first one, the answer is no, it doesn't. So yes, it is a function. Okay, and then with this one, now this one's a little bit trickier. We're going to have to plug in numbers and see what we get. Okay, so we'll just make a little t-chart. Let's start off with 0. And when we plug in 0, we get 0 squared is 0. 2 times 0 is 0. So all we're left with is 1. Okay, now let's plug in 1 here. 1 squared is 1. And then times 2 is 2. Plus 1 is 3. Okay, what about -1? Let's try -1. -1 times -1 is +1. So -1 squared is +1. Times 2 is 2. Plus 1 is also 3. Okay, and you'll get the hang of parabolas as we go. Parabolas mirror each other. Okay, so if we do 2, 2 squared is 4. 4 times 2 is 8. Plus 1 is 9. So then, since it's a mirror, then -2 is also going to be 9. All right, and we have enough points to graph here. So we're going to plot 0, 0. Oh, hold on, 0, 1. My fault. 0, 1. Okay, and then 1, 3. So right here. And then also -1, 3. And then we go up to 2, 9. So 4, 5, 6, 7, 8, 9, all the way up here. And then we're also at -2, 9. Remember, it mirrors each other. It's symmetrical. Okay. Now, technically, this is actually a parabola. So we draw a line in it. Do your best. Now, vertical line test. Does it pass? Vertical line, vertical line, vertical line. Kind of vertical line. Sorry about that. I could just use the straight line feature, but that'd be too easy. Moral of the story is, yes, this is a function as well. Because it passes a vertical line test. It'll never cross the graph twice. Okay. Now, function notation. You experienced it. Oh, you didn't experience it. We're so used to y equals whatever. Okay, when we're talking about functions, you'll see f of x. And really, it's just a fancy y. Okay, it's the same thing as y, but we just say f of x, so the function of x, 2x plus 5. Okay, so for here, the function t of x represents the number of words, t of x, that Rachel can type in x minutes. How many words can she type in 7 minutes? Okay, so if t of x equals 65x, and we want to figure out after 7 minutes how many words can she type, what we're going to do is we're going to do t of 7. So we're just going to plug in 7 for x. Now, common confusion. The answer, the output here is not 7. It's saying we're going to evaluate the equation when x is 7. Okay, we plugged in 7 for x. And so t of 7, 65 times 7, let me grab a calculator here, 455 words. Okay, so you can think of this as like, how many words did she type after 7 minutes? We plug it in, we get 455. Okay. So the function g of x, 5x plus 11, it represents the number of gallons wasted after x minutes. So how many gallons have been wasted after 20 minutes? So we plug in 20 for x, g of 20, 5 times 20 plus 11. And so g of 20 equals 100 plus 11, and g of 20 equals 111. And I realize I forgot my parenthesis here. So remember, the answer is not 20. The answer would be 111. This is just saying we're plugging in 20 into this function, and this is what we get out. All right. That is day 1. Here are your practice problems.